Good afternoon. I created this video to talk about how to incorporate various aspects of app development related to Bluetooth Low Energy, auto start services using Amazon Web Service, cloud databases, and initially I was going to talk about React Native a little bit, but I decided to parse that piece of it out because it seemed to be a little bit too much for the format here. So to start big picture, this video talks about my experience over the last couple months learning and gathering skills about Android OS specifically. Building an Android OS auto start service, one that starts after boot of the phone, collects information from a microcontroller. Specifically, I use an Arduino Nano IoT 33, but a lot of the skills, a lot of the methods transfer over to any Bluetooth Low Energy device because Bluetooth Low Energy sets a protocol and a way for presenting information that is standardized across multiple devices. That's the whole point of Bluetooth and Bluetooth Low Energy, is to provide that sort of standardized interface. So building an auto start service that can run with or without a UI or an associated activity. Collect that information, sort it, organize it, perform whatever necessary post-processing there is, and then upload that information directly to DynamoDB, where it could be used by other parties. And these other parties could not even be part of the Android family, right? They could be iOS devices, web apps, anything that has access to the internet and can parse through this AWS DynamoDB database. Now, the direction of information flow is not one way. We do expect our Android device to perform a sort of handshake with the Bluetooth Low Energy device. Specifically, it will provide the device some information about whether a value has been read or not. And this is going to help the Arduino save energy. In other words, it can shut off its Bluetooth Low Energy transmission, go to sleep when it has detected that the value has been read. And obviously, the service may desire to take information from AWS DynamoDB at certain points. Now, React Native, I have a decent amount of experience with both React and React Native, with React being the web app version and React Native being that which is able to interface with native code for Android or iOS. It is a much different subject, and so there are a couple parts of this mini tutorial that talk about React Native. I have pulled most of that information out, and so there's a couple hanging references, but not too many. Now, about the difficulty of this, it's medium difficulty, and it's not always consistent. Um, there's a lot of information being presented here, and so it would have been really difficult to brush over all of the background and just jump straight to the main application, because I think that for a lot of even moderately experienced programmers, there may have been some missing pieces. On the other hand, it's also going to be impossible to approach this from the ground up um, because there's going to be so many moving parts, right? We can't possibly provide background on every necessary piece. We will talk briefly about how to use Amazon Web Services, but you'll probably need a separate resource in order to learn more about that. We do talk a little bit about the basics of Android OS programming, but if you're not very familiar with Java and the use of custom APIs, you may need to do some background research or background learning there. So we are going to start from the end and work back towards the beginning in building or demonstrating how we have built an auto start service in Android that collects Bluetooth data automatically from an Arduino device properly configured, takes that data, does some slight post-processing, and then uploads that directly to DynamoDB. Now, later on, when I talk about the process that I used to get to this point, you're going to see that along the way, parts of this were different. I used fewer components, and I had different ways of listing the lists of Bluetooth devices and services and characteristics. But this is the final version. So for those of you that have a lot of experience in this type of programming, this is a good starting point. But for those of you that perhaps need a little bit more background, I propose or I suggest you move a little bit forward into the video, and I'll put a nice break or something that demonstrates when we're going back into the background section of this. So this is the main Bluetooth service, and this is really the part of the code that does everything. We define several class variables, member variables. We have the Bluetooth generic attribute profile, the Gatt, which we call mgat Ble. We have the map Gatt Ble 007, which we call mrecord Gatt Ble. We'll talk about that in 1 second as well. And then we have an array list of the Bluetooth devices. So we'll be collecting a list of Bluetooth devices here in our service. So now let's take a look at mgat Ble 007 a little bit more closely. All right, so this is our mgat Ble, and essentially the role that this fulfills is, as you can see here, it provides a method for storing and organizing a given device and all of its services and characteristics. We had initially developed it to be parcelable, but later on we backtrack on that because we saw there was really no need, although at the bottom I'm sure you'll see some remnants of that. So the class variables here, we have to pass in the context only because if we want to send broadcasts or make a toast type announcement to the user, then we'll need the context. We also have a list of the Bluetooth services associated with this device. So this is a map of a given Gatt, general attribute profile for Bluetooth Low Energy. We also define a form of the services and characteristics as a JavaScript object notation array, and later we're going to take everything and compile it into that. Now, as we cycle through the services and the characteristics, we're going to use publicly, or not public, but member variables called mServiceIndexK and mCharacterIndexK. So you can see here, this is the constructor for this map, and it has several different characteristics. The context, the list of services, the JSON array, the indices, etc., etc. Now, we're going to build this using a Java Bean-based mapping, and that has certain rules with regard to how we name the getter and setter methods. These are pretty straightforward. We can get the service, we can get a characteristic, and what this does when there's no value in here in the input, it just returns whatever the current service or current characteristic is. There's also a version of getService where you can supply an index and then it would return the appropriate service to you. You can also get the unique identifier for a service based on the input you provide, the name of the characteristic, the value of the characteristic, a random ID that I associate with each characteristic, and then the status. So when we go back and talk about the structure of the firmware, you'll see that all four of these go together. Each service, or the way that I've set it up, the service has four characteristics which go together. One is the name, the value, a random ID, and a status. So the status will tell the firmware of the device whether the given characteristic has been read or not already. And this random ID is something that I just incorporated in there to allow us to differentiate between different readings, different inputs from the BLE. So we can compare. Chances are it won't generate the same random number twice, and we can see, well, if those random IDs don't match, even if the values match, we can tell that they're most probably different readings. The get character attribute that takes in the service as well as the character indices, and so without going into too much detail, if the first, we make sure that the index is in the desired range. We cycle through all the characteristics within the service. We load the 8th character of that character's UUID. The only reason why I did it this way is because I named all of my characteristics 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, and then something. So I only need that last character in order to identify it. Now, if the I type is equal to the characteristic type in, then we will return that value. And so what we're seeing here is that essentially, when we say type, does it have the appropriate UUID? So therefore, if we're looking for 0, 0, 0, 0, 0, 0, 1, it will, here is where we determine or make sure that the code only takes that characteristic. This command right here takes the so we have the Gatt characteristic k, we get the integer value, and then we format it as an unsigned integer 16 with an offset of 0, and that returns our value, and then we can simply return that, and that gives the characteristic value. Next, we define the set methods. We didn't really define any here because we're not going to use them. We then have the add methods. So this method allows us to add a service once it is discovered to this map, which is the map Gatt Ble 007. This is pretty straightforward. We take our list, we add the new service, we create a new JSON object which will represent that service. We populate it with the UUID, with the name, the value, random ID, and status, all the things that we talked about before. And then we put that into our mJSON array. So that saves it to the mJSON array. There are some other private methods in here which are not as important. One generates a string, and let's see here. These are not really that important. We obviously need to have a method that allows us to increment the indices. And so what this does is takes care of, let's say we go from service 1 that has 2 characteristics, then we go to the second characteristic, right? It knows that when we get to the third characteristic of the first service, it automatically has to switch over to the next service. We also have a function that checks if it's the last characteristic, if it's the first characteristic, and then lastly a method that turns our service into a JSON. So actually there's 2 versions of this. This one does it for one service only, and this one does it for everything that's contained within the map. And then at the bottom here you can see where we had code to make it parcelable, but in the end that wasn't needed.
Okay, so that is this, the map Gatt Ble 007. Next, in our service, we're going back to the main Ble service. We define the listeners and the listener instances. I said before that we use a combination of broadcasts and listeners, really just because when I started the code, I was using broadcast receivers, and then I switched over to listeners, so it's sort of half and half. So we have a private class which is listener write to DDB 003. It implements a given interface, which we'll take a look at in a second. And essentially, it just displays the notifier to the user. We also have to define the notifier and listener instances, and so that is done here. So the notifier is associated with an event, and that event is associated with a listener, and that creates the communication chain. So first, we create the instance of the listener, then we associate it with the appropriate event interface and notifier. So let's take a look at this interface right here and see exactly what that is. So we interface event notifier 006. Okay, so I think that's this right here. And so reading the note, so next we need to define a notifier. The notifier controls the flow of information between it and the listener. While the listener itself defines what happens when the event is detected, the listener does not say much about the flow of information. This notifier was designed to trigger one asynchronous event upon completion of another. In other words, it informs a listener that an asynchronous task is done, as well as passes generic results between these tasks. We made it generic so we can use it in multiple ways. This notifier is associated with the interface, and allows synchronization and ordering of asynchronous tasks. So the interface is, sorry about that, is not super complex. We define the interface event notifier class, and first within it we define the interface. It is the basis of the listener because it defines exactly what function and attributes are to be used. It essentially defines the structure and the bones of the listener. This interface was set up to pass results, generic objects between events, often within separate threads within the application. And so there's just a single method, pass results, and it passes some generic object, as well as we can include some message in there as well if we want. The rest of the class, we have to define the class attributes, which the main one is essentially just the listener, which is going to be passed to it. The initialization constructor, again, what we have is the listener that is passed to it. We set the listener using this command, and then we define the pass results method, which is essentially just triggers the pass results method associated with the listener. Okay, so now let's talk about the listener to write DDB 003. And actually, I should have realized this is defined above inside of our own class here. Okay, we still are using broadcast receivers. This is a generic one. We just use it to pass anything that we need in order to display a message to the user. And then we have the receiver add device, and you'll see this is one that is present in most other versions of the code. So once it receives a broadcast that indicates that a new device has been found by the discovery method, we extract the Bluetooth device called device in from the intent, and then we add the device in to the list of devices, which is up here. So what we're doing is allowing ourselves to create a list of devices. Now this is really where the method, the service starts. This is a non-bound or non-binded service, so it's executed on the onStart command. And so we initialize an object to represent the Gatt. This again goes back to our map Gatt Ble 007, which I think we have already talked about. We then register the broadcast receivers, create the appropriate intent filters. If when we go into the code, we can take a look at that. And then we check the permissions. Again, this is something, I didn't put too much detail here. If you want to look at later, or well, later in this case, but it's really earlier versions of the code, it shows explicitly what commands you can use. They're provided by the what's called Android Service Library. And it actually makes it really easy to check if we have the appropriate Bluetooth permissions, as well as, really important, this access course location permission. And then we essentially call the method start discovery. So this works like a chain, where the methods call one another in a very specific method which controls the flow of information. So let's jump down to start discovery. So we define both the Bluetooth manager and the Bluetooth adapters named mBluetooth manager and mAdapter Ble, and this allows us, both of them allow us to interface and interact with the Bluetooth device. If Bluetooth is enabled, then we can actually start the discovery process. So this command right here, not this one, this houses it. This actually starts the discovery, and this is from the API, and it starts the discovery process. Now from here, we need to go to one of the methods in our callback, which we'll talk about in a second. And so on services discovered, we go down here. So once a service is discovered, it will pass a Bluetooth Gatt in as well as a status. If the status tells us that it's successful, then we will cycle through all of the services and add the services to the mRecord Ble, which again, if you remember, mRecord Ble is of the type map Gatt Ble 007. That's the first set of code that we sort of went into and discussed. Okay, so on discovery. Then, continuing the chain, the mGatt Ble will then attempt to read the characteristic of that mRecord Gatt Ble, and because we haven't included an index right here, we're just going to try to pull out the current end index. Because the methods are public, we can increment the indices from the service itself. Okay, so then once we trigger a characteristic read, we move into, and again, these are all part of our callback function. On characteristic read, it passes us in the Gatt, the characteristic, and the status. If the status is success, then we load the value as an unsigned 16-bit integer. You can see right here, int read, which is unsigned 16, characteristic in, get the integer value. We format it appropriately, and that gives us the value. Now, if this characteristic requires a handshake or a status update, we do that. Essentially, there's only one that requires that, and that's the one that's of type status. We talked about that. There was the name, there was the value, there was the random ID, and then there was the status. So if this is the status characteristic we're talking about, then we'll set a value of +1 to that characteristic, and then write it. So these two commands go together. When you want to read a value or write a value, it's a two-step process. In this case, you first set the value to our characteristic internally, and then we write that characteristic, which contains the new value, to our Bluetooth device, and so that takes us down here to on characteristic write. And so essentially, we check for success. We really don't have, I don't have anything built in here for a lack of success. Probably should include some sort of error handling. But if it's successful, then we go back to read characteristic in. And the reason why we do that is because we want to make sure that the status update went through. So it was 0 before, and it should be 1 now. So we're back up here on uncharacteristic read. We go through all of these steps. We'll see that the characteristic no longer requires a handshake or a status update because it already has a value of 1. And then here is where things branch out. So if we are not dealing with the last characteristic, then we need to keep reading. And so that moves us into read next characteristic, going all the way down here. Read next characteristic does several things. First, if this is the first characteristic, then it returns a null. And the reason for that is because read next characteristic will never be called on the first characteristic. That's done initially. So if we come back to our first characteristic, that essentially means that we're done. Now, if that's not the case, then we move down here, and we essentially we get the next characteristic. I don't know if I neglected in here. There should be something about incrementing the indices. And when we get to the code, we'll take a look at that, because if we're not including a value here, then it would read the same value over. So we need to increment the indices in there. Now, if the next characteristic provides read permission, then we'll read the characteristic and go back up to characteristic read, and you see the same process. If it's not the last characteristic, then we go back to read next characteristic, and over it moves the characteristics from the Bluetooth device to our, well, let's take a look here real quick. So we read characteristic, on characteristic read. Yeah, here again we get the integer values. So each time we enter on characteristic read, we're loading new values into our record. Okay, so we go through this several times, back and forth, back and forth, back and forth, and then eventually we get to a point where we are at the last characteristic. And at that point, we save the data to DynamoDB. Okay, now that all the characteristics are read, we can save the data to DynamoDB. We create a map, and this is another map, map DDB04, and all the inputs go in there, all the values that we've read. So let's take a look at map DDB04. Oops. And so this map is the one that must interface with our table. And so you can see here, it's a very specific structure. This is the mapper. We have to clearly state the table that we are going to, well, it's really big, the table that we are going to be interfacing with. And it should be implemented as parcelable. So here we have the attributes similar to what we saw for the other map, except we add new values. The hash key, we add a user ID, we add a timestamp. Session length is what we were calling value before. The random ID is the same, the status, and we also give the opportunity to add a user log or a message. The constructor classes are relatively straightforward. We have a no argument constructor, and then we have a constructor that accepts inputs. We have our get methods, again, really not too much to see here, and we have our setter methods, which again, not much to see here, it just saves the values. Generate string method, again, not very interesting. And then we have our parseable methods. And so if you don't have too much background on this, you can go forward in the video and take a look at how it works. But essentially, you need a method to create the parcel, and then essentially, well, sorry, this scrolled down. And then, so this is to read from the parcel and to write to the parcel. The important thing here is the order and the types. So we need to make sure that it goes, so string, 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 int, int, int. String, 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 int, int, int. And again, hash key, then user ID, then timestamp, then session length. And then the rest of this is just generic code that's required for the parcel. Okay, so that creates the element to save. Now this, again, if you're not familiar with this, it's very important that you read up on, you might want to try saving some elements to DynamoDB before you dive into this because, right, it's a very specific way that you have to do it. I mean, I highlighted all of the important parts, but, there's always some nuances that might have been missed. We then create our table, DDB05. We need to take a look at that. I don't think we've seen that yet.
And so we jump into our table DDB05. Now, this is going to be a class that allows us to interact with the table relatively easily. We pass into it the Cognito caching credentials provider, which again is something, if you're not too familiar with, take a look at later parts of the video, it explains it. We also need a DynamoDB client as well as the mapper, which we already defined previously. We also pass in the context. So the table, we have the context passed in. This I copy directly from AWS Cognito. I create the client from the credentials provider, make sure to set the region. I actually got into had a lot of frustration when I did not set this properly, and I had some inability to communicate with the table. We'll then build the mapper using our client. And now we, we don't create the element here. What we did, so this is all set up, hence why it's in the constructor. We created an asynchronous task. Async read one item. It requires a notifier, so this allows us to attach a listener to it, and the hash key in for the element that we are trying to read. And so what we do is we use a runnable in order to execute this code here on a separate thread as called down here. So again, we create an instance of our map DDB04. We load the appropriate value according to the hash key. This is where it actually brings the value from DynamoDB, and then it displays it to the user, and we pass that result back using the listener. We also have a similar async write one item. Note that these methods are public, so we have access to them in the service. Async write one item runs in a similar manner. We build everything inside of a runnable, which then is executed on a separate thread here. The async write one item requires a notifier, so that allows us to communicate back using a listener, and then also a complete map of the element that we want to write, because when we're reading, all we need is the hash key because we're just searching for the value. When we're writing, we need the entire map with all the values included. So we have mapper DDB. We use the command save. We write that. And then essentially what we do is we load it again in order just to make sure that it worked. And then we pass that back. And so that is the bulk of the table DDB05. And we'll see when we go back to this right here. I think I've lost my spot, unfortunately. Okay, so we declare an instance of our table right here, and then we use the async write one item method that we saw before to take our data and write it into the cloud itself. And so that really is the end of the service because it's completed its task, which is to load up all the services, all the characteristics, read all of them, and then write them to DynamoDB. And so you can see here, it's relatively lengthy. There were some ways that we could have shortened it perhaps, but from the initial testing, it works very well. So let's take a look at the code for the service itself. I'm not going to go into too much detail here because we have explained it in pretty good detail in that flowchart, but we'll go through it quickly. So we have our service. It obviously extends object type service, right? We define our member variables. There's some masks, bit masks we have to define. We create a listener, which essentially you can see here just passes results of type map DDB004 back to, well, it receives that type of information. That's the type of object that it is, and so we cast it to the appropriate object. We know what type of object is coming in. We define the event notifier and listener instances. We talked about that. The broadcast receiver instances. The main one, the most important one is this one, receiver add device, which physically adds devices to our list of Bluetooth devices. Following our flowchart, we have our onStart command. This is where everything really starts. We register our broadcast receivers. We check for permissions. And so here now you can see the exact code you need to check for permissions. And so there's some nice commands that are provided by the Android service library. And so we can simply just say check for self-permission and then put in the appropriate permission that we're looking for. If it is not there, then we send out an error message. If it is, then next we check to see if Bluetooth is supported. So some of these details were not in the flowchart per se. So we check to see if this feature is supported. If it is, then if it's not, we send out a message. If it is, then we start discovery, which we talked about that method before. So start discovery initializes the Bluetooth manager, the Bluetooth adapter. It checks for Bluetooth functionality as well as the status to make sure that it's on. If it's not, then the user has to do something. If it is, then we start the discovery process. And so if the discovery process times out, and actually it seems like this is one part of the flowchart we may have neglected to look at because of the way that we were parsing through it. We skipped down to on services discovered, and we never came back to here, which is what happens when the services are discovered. So essentially what we do is we execute a runnable. This is not on a separate thread, but it is delayed. And the reason for that is because our goal is to have the discovery process run for a certain length of time. After that that time period has completed, we cancel the discovery process and we find the target device. So this is a method all the way down here at the bottom, and it essentially searches through the list of mlist devices BLE and returns the desired device. There's lots of different ways you can do that. The way that I did it was through the prefix of the name. So the way that I did this, the user doesn't have to go into settings and connect the Bluetooth radio in the phone to the device. It automatically does that. Okay, so going back up here, right, we find the target device. If we don't have a good connection target, meaning we don't find something with the appropriate prefix, then it starts the discovery process all over again. And it just keeps looping, discovering. We put a couple delays in there to prevent it from continuing without end. And actually, I neglected to note this read everything from BLE method. So the read everything from BLE method, this is what and connects to the Gatt and initializes everything else. So read everything from BLE, it passes in our desired device and sets that as our mgat BLE, connects to the Gatt server, and this is where the callback is executed, and then it returns true, stating that we have a successful connection. And then in here, in the callback, you'll notice these are all of the functions that we had referenced before. On connection state change, we start to discover services. Once we start to discover services, that moves us into on services discovered and on, as I explained before. So again, sorry I forgot this little chunk of the code. Sometimes it's difficult to read these types of flowcharts. But I think we did a good job of going back and bringing that piece back in. So now back to the code. So this is where we are. We check the Bluetooth adapter. We start the discovery right here. We have a delay down here, which post delays the runnable. Once it's complete, or once that delay is over, we cancel the discovery. We try to find the appropriate target device. And then again, if we don't, we have another runnable which delays and starts discovery again. If we do find the appropriate device, from up here, we pass it down into our read everything from BLE method, which is where, let's see here, read next characteristic, I think it's above. Read everything from BLE. Okay, so now we're in here. We've passed in the result from find target device. And it connects the Gatt, executing or passing the callback, what we call the Gatt callback, to this. And so the Gatt callback, the Bluetooth Gatt callback, we call it callback read everything. This is what sets up the loop of operation that we talked about before. On connection state change, if we have an appropriate device that's been connected to, we start discovering services. So that moves us down here to on services discovered. If a service is discovered, we add it to the list, and then we read the characteristic from the first service. That moves us down to on read characteristic, which then checks for success, checks to make sure the val isn't null. Here's where we actually load the value, again, as an integer. We check for the character type, the characteristic, not character, characteristic type. If it's the type that needs to be written to, then we write, this is the handshake, we write the value back to the Arduino. And if it's the last characteristic, if it's not the last characteristic, we read the next characteristic. If it is, like I said before, we move on to saving the data to DynamoDB as shown in here. We create our map. And then lastly, we call the async write one item method from our table DynamoDB on characteristic write. So when we wrote up here, this would also be triggered and would tell us whether the write was successful or not. The read next characteristic method, and so here you can see I left this out in the flowchart, the incrementing of the target indices. When we read the next characteristic, we have to make sure to increment those, or else we'll be reading the same characteristic over and over again. But the rest is pretty much the same. We load the properties and permissions bit masks. We make sure that we have the permission to read If we do, we read the characteristic, which will push us back up to on characteristic read. That goes around and around and around, as we showed before, and then ends right here, right? It ends right here and goes back out to the, returns. Well, essentially, it writes it to DynamoDB, and that's the end of the process. And at that point, the Arduino is told that it can go to sleep. Okay, so I want to see if there's any important code that we haven't taken a look at. We looked at the main service receiver after boot. This is one we didn't talk about. In order to have the service be called upon boot, what we do is we declare a broadcast receiver in the Android manifest. That receives the intent with an action type of, I forget what the name of it is, boot complete or something like that, and essentially just routes that directly to starting the service that is the service that we have been spending most of our time talking about. So you do need that at the beginning in order to make sure that this works. So we've talked about receiver after boot, map Gatt Ble, map DDB, main service, interface notifier. The activity itself is really just used the first time that the app is run. Because the first time the app is run, we do need to use this code here specifically to ask the user to give us permission to access to have access course location permission. And then that will eventually call our service. Where's that? Yeah, here you can go. Here you can see. So service main, and then it starts to service, and then we go from there. So this activity is only required the first time that we run the app. It's the only way that we can get permission from the user. But after that point, when the phone boots, it will simply start the service with no UI associated with it. So I think those are all of the important parts of this right here. So this is the basic structure of the service. Again, you have your class variables, which are mostly the member variables are used to keep track of what's going on. We have our listeners and listener instances, which are used to or to retrieve values from other parts of the application. We use broadcast receivers for something similar. On the onStart command, we create our Gatt Ble. I mean, I don't want to reread all of this, but you can see again, if you rewind the video, you can see how this loop works. The loop, in basic terms, calls read everything from Ble, goes up here, connects the Gatt, goes to the call back read everything. Then on connection state change, starts discovering services, which leads us down here. Once a service is discovered, it cycles through all the services, reads their characteristics, which leads us down here. On read characteristic, it reads the value, provides the handshake if need be. If it's not the last characteristic, we move on to the next characteristic. Here, we read the next characteristic. Don't forget the incrementing, which I did not include in the flowchart. We get the characteristic. If we have read permission, we read it, which moves us up to on characteristic read, and then read next characteristic over and over again. One thing to note is that if we don't have permission to read a characteristic, it will simply skip and go straight to read next characteristic. It will not try to read that, and it'll increment and keep going on and on and on. And again, the endpoint is right here. If we are at the last characteristic, actually, I think I changed this to first characteristic because that made more sense. Anyway, but if we know that the process is done, then we save the data to DynamoDB and we are done. So hopefully that gives you a really, I don't know what the right word would be, a nice balance between a basic overview of how something like this would work and an in-depth look at it where we would be parsing through every line of code and talking about every single thing. If you have questions, feel free to put them in the comment section and I will do my best to address them. So, right, this achieves all of our goals that we had set up in the beginning, which were to read from our Bluetooth device, which is an Arduino in this case. We have our Android app, which reads the Bluetooth, provides some handshake, does some processing, it changes the form, storing it into the appropriate classes, and then moves it into the form of map DDB04, which is what we can send directly to DynamoDB. DDB004, and then that saves, and then it ends. And so from there, right now that's where it ends. I guess we could define it to go back into discovery mode. Well, not discovery mode, but searching for updates in the services or the characteristics. But actually, I haven't implemented that part of it yet. But it's an easy fix. So this is the end. This is what we achieved. I mean, I could go into Amazon Web Services and show you that the data is uploaded, but I don't know if that's necessarily going to be very productive. So now let's go to the beginning. And the rest of this video is going to show the steps of how I got to this. We'll talk about more granular parts of this. It talks about what intents are, how we use listeners, broadcast receivers. It talks about the Amazon Web Services API. It talks about the Bluetooth API, and gives some smaller examples that lead up to this one. So that will be the next section of this video that starts right here. So we are going to start off with some background, and if you feel like this starting point is too elementary for you, this is, these are objects and aspects of programming that you're already very familiar with, I recommend you just fast forward the video to a later point. There's really good headers and heading labels in this, so you should be able to scan and sort of see where a good stopping point will be. But I am going to provide some background on different objects and aspects of Java programming or programming in general that I needed a slight refresher on before jumping into this project. I went back and made notes about those. So broadcast intents, this is the first one. So Android OS apps can send or receive broadcast messages from the Android system or other apps using something like the publish and subscribe design pattern. The publish describe messaging pattern allows a subscriber type object to register for messages from a publisher and be sent following an interest event of interest. For example, a subscriber may ask for messages from a publisher with information about the availability of new Bluetooth or Wi-Fi connections, only to be sent when a new connection is detected. The broadcast message itself is wrapped within an intent object, whose broadcast action string identifies the type of event that occurred. One example would be Android intent.action.airplane mode, and this obviously would tell an application or a service that airplane mode has been activated. The intent may also include additional information bundled into its extra field, and for that we normally use the put extra, ran out of room, but put extra command. We may describe the broadcast as a broadcast intent because it is essentially an intent with specific predefined attributes. A broadcast receiver class allows us to receive and handle these broadcasts sent by this command here. There is one necessary method called onReceive, which describes what actions follow a message being obviously received. Below is a very generic example of a broadcast receiver class. So the receiver is called myReceiver. We have a constructor, and then we have the onReceive method, and it just simply displays the results to the user. So broadcasts and broadcast receivers. The reason why I brought that up is because this, in addition to listeners, will be used to pass information back and forth between an activity or a UI as well as a service or, well, different parts of our application. Intents and intent filters. So by this point, we should be aware of what an intent is. It's an abstract description of an operation to be performed. Commonly, we use intents to bring up other screens, aka activities, within the app. It can also be used to start services. An intent filter is a structured description of intent values to be matched. It's a filter. It tells, so if we register a broadcast receiver with a given intent filter, what that does is says, okay, the broadcast receiver is listening for these specific types of broadcasts or broadcasts that meet these certain requirements with regard to the action string. Note that because a broadcast message is wrapped within an intent, right, the intent filter can be used to filter these messages. That makes sense. And so here you can see the basic way that we define that or declare that within our Android application. We define an intent filter, we set the action string, and then we register the receiver. This is the receiver name right here with the filter. This project, the next topic we're going to discuss is permissions. This project requires us to request permission to access the mobile device's location. And this is a side effect of the Bluetooth low energy. As such, we need to learn about permissions. Google recently made changes to how these are handled. The purpose of a permission is to protect the privacy of the Android user, and Android apps must request permission to access sensitive data, such as location, as well as certain system features, the camera or internet. One important difference here is that some permissions may be granted automatically by the system, while others require explicit approval. An app publicizes the permissions it requires within its manifest via the uses permission tags. There's two different types. Normal permissions are those that don't pose that much risk to the user's privacy or the device's operation. The system automatically grants permission for any request listed in the manifest that's of the type normal. Dangerous permissions are ones that request location information or perhaps access to the camera. And so these could have a detrimental effect. The system does not automatically grant permission for these requests, even if they are listed using the appropriate tag in the manifest. They must be granted permission by the user explicitly. As stated above, only dangerous permissions require user agreement or user consent. And the way that Android asks a user to grant this permission depends on the OS version. We will focus on the process for newer versions of Android. Older versions requested the permission once during installation, while newer versions request such permissions at runtime. The user will see a dialog like that shown below with allow and deny buttons. And this is how specifically we are going to request permission to access course, which is the opposite of find, location. Next, we are going to discuss how to use the Android support library to check for and request permissions. This is nice because the Android support library provides us essentially really simple commands that will automatically check for these permissions for us. That will generate the dialog box, and update the permission status within the app automatically. It's really easy. So in order to do this, we follow these steps. One, we add the permission to the manifest. Whether it's a normal or a dangerous permission, we still need to list it in the manifest. Next, we check for permissions using the code shown in figure 12 and 13 below. Right, this is our manifest right here, and down here we can see where we're checking for permission. And so you can see, if I can make this a little bit bigger, context compat dot self check self permission. You include the context. Again, you don't need to use get React application context because we're not going to be focusing on React. You would just use this, or you could say get application context. And then you need to include the appropriate permission that we're looking for, which in this case is access course location. And then if you don't have permission, you can see in the green box, we can request the permission using this fairly standardized command. So like I said, it's nice. It's already prepackaged and ready for us to use. Now, where does this code go? Because we are talking about permissions within the construct of, well, we're not talking about building React Native, so I can actually skip this. This would just go in the main activity. And then third, we need to request the permission if it's not given, and we already showed that code is in the green box. And so here you can see the app asking for permission. Services. Now, services are obviously an important part of this project because we are trying to build an auto start service. So for this project, we will eventually have to create a service. This is an application component that can perform long-running operations and does not provide necessarily a user interface. You can have a user interface that interacts with it, but we don't necessarily have to. Another application component can start a service, and it may continue to run in the background even if the user switches to another application. There are three different types of services. Foreground, a started and non-bound or non-binded, I'm not sure exactly what the correct verb would be there. Foreground service that performs an operation that is directly noticeable by the user. For example, an audio app would use a foreground service to play an audio track. Foreground services must display a notification. They continue running even when the user isn't interacting with the app. A background app is a started or non-bound / non-binded background service. It performs an operation that isn't directly noticed by the user. For example, we could have an app that uses the service to compact storage. That would be in the background. It wouldn't be noticeable by the user. For API level 26 or higher, the use of background services is more restricted, especially for those that access location information. A service is bound. So this is the third type we're talking about now. When an application component binds to it by calling the bind service method. So there's essentially two types of services. There's the type that is bound or binded, and then there's the non-binded. And really, the main difference is how we start and initiate or instantiate that service. The bound service is going to be bound to a given activity or other component. The non-bound is going to be just started and essentially will run independently, completely independently of any activity or any other part of the application. So next we want to outline the basic structure of a service. I am not going to go into too much detail here because although I'm trying to give background on services, I'm not trying to teach a course, or not a course, but give a tutorial on services alone. So you need to have the instance of the iBinder. The iBinder is an object that allows you to pass the service back to the activity, and this is used in combination with your local binder, which you will define. You need to have an onBind method, an onStart method potentially if you are building a non-bound service, and then other services. So the other services would be those that really do the work. We also want to outline the basic structure of an activity that calls a bound service. We need to first define an instance of the service, bind the service to a connection, call the method if it's bound, and then we also need to define the service connection that is associated with it. And so we can see this is an example of a bound service. Don't really think there's too much here that I can talk about that I haven't already said, right? We have our local binder, we have our onBind method, and then we have a simple method, which is get hello world, which simply just returns hello world. I'll briefly show a non-bound service example. So this would be one where we would use the start service command in order to execute it. So here, right, we can see the service, and it's actually much simpler, the design of it, where we simply have an onStart command. This again is just displaying some sort of a message to the user, and then we still have the onBind method, which is just required of a service regardless of the type that we use. Okay, so I want to skip forward a little bit more quickly here. Right, these figures, you can see the custom service with two different methods that we were actually just looking at that example. We call the service within, so this figure right here actually shows how we call the service within the constructor of the application. And so what we do is we create an intent. Again, we use intents to start other activities, to start services. And so the intent has embedded within it the class we are trying, the service we're trying to call, which is called new Android service 003. We also added an extra to this intent, just a little message to pass along with it. And then we say this, you don't need the get reaction application context because this was when I was trying to interact with React Native. You could just do this dot start service or get application context dot start service. Over here on the right, we can see that the service also needs to be defined within the application manifest, which is maybe something that I didn't draw enough attention to in the beginning. So moving on to threads, this is probably one that almost anyone who does mobile application development should be familiar with. Right, a thread is a thread of execution of a program. The Java virtual machine allows an application to have multiple threads of execution running at once. Every thread has a priority, with higher priority threads executed over those with a lower priority. Every thread is marked, and with certain threads able to run as background processes rather than being under direct control of an interactive user. When code creates a new thread object, the child initially has the same priority and status as the parent thread. When the Java virtual machine starts, there's usually a single thread called main, and then the machine continues to execute threads until one of the following occurs. Either a thread is exited, or it returns a value or throws an exception. There are two ways to create a new thread of execution. Actually, probably more than that. There's two that I commonly use. One is using the thread subclass. So we declare a class to be an extension of class thread, and then this subclass would have the member method run, and then that would execute on a separate thread. We can also use the Runnable interface, which we're not going to focus on here initially. I think we do use it later on, but we can use Runnable to also implement a separate thread. So here we have a really basic thread example. To clarify, we'll demonstrate how one may create a new child thread that performs a simple process and then returns that information to the parent via broadcast. So here again, broadcast is going to be important because the thread is not necessarily going to be able to return a value to the application or to the activity that calls it. And so here, this is a general structure of the code. We have the main thread, which defines an instance of this class thread over here on the right-hand side. So the left-hand side is the main thread, and the right-hand side is the thread class. We start a new child thread, which then we follow the green arrow over to the thread class. The constructor will be called, obviously, and then the run method will define what happens when we call .run. It can perform any simple processing. It can create a broadcast to be sent back to the main thread. Normally, we'll create a broadcast and send that broadcast back to the broadcast receiver. And so that broadcast receiver will determine what happens to the outputs, which will be passed to the main thread as extras within the intent. And we can display that to the user and do whatever else we need to do. One important part, which is also stated in here, before our main thread can listen to responses from that thread class on the right-hand side, we need to define an instance of the broadcast receiver, create an appropriate intent filter, and register the broadcast receiver. So those are steps 3, 4, and 5. So this is a really basic example of how we can take a main activity, we can create a new thread, we can have it do something, and we can then have it pass information back to the main thread using a broadcast receiver. We'll see later that we can also use listeners for this. I mean, there's multiple different ways that we could do this. Okay, another object that we're going to talk about is a runnable. So the runnable interface should be implemented by any class whose instances are intended to be executed by a thread. So let's review what those terms mean. This is really basic stuff, but class, right? This is a basic class object used by most object-oriented programming languages. That's like a no-brainer. I'm sure everybody knows that. An interface is a completely abstract class that is used to group related methods with empty bodies. Okay, so an interface is like the definition of a class, but only just the inputs and the outputs. It doesn't say any of what is going on inside. And a runnable is a type of interface. This is an interface that should be implemented by any class whose instances are intended to be executed by a separate thread. The resulting class must define a method with no arguments called run. So you can see there's almost a hierarchy here, right? The runnable is one type of interface that's used to call separate threads. The interface is one type of class that only defines very specific parts of the class. And then the class is obviously the most generic object. Now, we should clarify that runnables are not threads. We can, however, pass a runnable object as an argument to a thread constructor, and therefore the task defined within the runnable's run method would be executed when we call thread.start. So this is a basic example. I think I derived it from one I found online. I apologize for not citing it properly. But let's say we have an interface that we called animal. Okay, and so the interface is a type of class. It just defines the methods and the let's say the member variables and member methods that should be associated with any instance of this interface. So the interface animal has two methods, animal sound and sleep. And then when we create a class that implements animal, interface animal, we have to then define what actually occurs inside of the animal sound and sleep methods. Now to the right, you can see an example of a runnable. And so essentially what we have done is, I'm sorry, I can't make this any bigger. We create a new thread. And so if we're focusing on the bottom here, sorry, this keeps turning black. So thread 3 is equal to a new thread that is then constructed from a runnable. And we're defining that inline there. So the runnable has one method, one member method, which is run. And essentially, let's see what it does. It looks like it just prints a really simple message or something like that. Runnable inner class runs, anyway, whatever it's doing. And then lastly, so there's two parts to this. We have to define the thread as well as start the thread. Now, at the top of this, you can see an example of us calling a predefined runnable. So it's almost the same thing. One is defining it in line, while the others is defined in another location. So the next question we may ask is, why use a runnable? So there's some overlap in the way that runnables and threads are used. For example, both of these can be used to achieve the same goal. We can define a thread with desired tasks and actions, or we can define a runnable and pass it to a thread, where this is an example that was shown above. So they're both almost the same thing, right? Both of them define a run method that is called or executed when we start the new thread. Why do we need an extra step? Why use a runnable? So there are three main reasons. One is modularity and reusability. When a separate thread runs and completes, there's no way to restart it. So creating separate threads for the same task can be inefficient and results in lots of duplicate code. By defining the thread from a runnable interface, it makes the code more modular and reusable because we can reuse the runnable interface over and over again. Ease of use. The runnable interface is easy to use, I guess, relatively. It has one method and accepts no arguments. This is different from a thread, which may have more methods that need to be defined. And then inheritance, a runnable interface supports inheritance. And so we have another example of a runnable. Oh, actually, it's above in figure 18, and we talked about that already. Next, we're going to talk a little bit more about interfaces and abstract classes, because I feel like this will provide some more context. Again, for those of you who are bored by this part, I encourage you to jump ahead and we'll get more into the advanced aspects of this project. And it's going to jump relatively quickly. We're going to go over the basics, and then we're going to jump straight into using the Bluetooth LE low energy API and all that type of stuff. So an abstract class is a restricted class that cannot be used to create objects. Therefore, the methods it contains may only be accessed through inheritance, very similar to an interface. For example, we can create an abstract class called food below, but we cannot create an instance using the command, essentially using the constructor. An abstract class may contain abstract methods that have no body and must be defined by the subclass. So it can be used, again, just like an interface. Now we can create a subclass burrito that extends food as shown below. It will define the body of all, it must define the body of all the abstract methods, which I guess we only have one abstract method. The second one is defined. Sleep is defined, but food taste is not. So how does this differ from an interface? An interface is completely abstract. It contains only abstract methods, but we can define, as shown up here, an abstract method where some, which the example being sleep, some of the methods can be defined. So it's sort of like a half abstract method. The only other difference is that class burrito would implement the interface as opposed to extending an abstract class. So in reality, almost exactly the same thing. Interfaces, abstract classes, what they do is they define a structure for a class that we can use for different similar types of objects where we don't necessarily want a very uniform treatment of inputs every time. Another topic that we're going to need to discuss is the issue of serialize ability and creating classes or objects that can be packaged in a serial or parcelable manner. So serializable is an interface that allows the state of a class object to be serialized into a single package. And serialization is managed by three different methods. We have write and read object, essentially. We'll talk about how this works in a second. So in short, write object writes the states to a stream, and read object can restore it. The key here is the order. Everything needs to be done in the appropriate order, or else the method will not properly pack and unpack the state. So parseable is an Android implementation of the Java serializable interface. It assumes a certain structure and way of processing it, making parseable objects more efficient. Now, one primary way in which we're going to use parseable is when we want to take certain class objects that maybe have lots of different attributes, etc., and we want to pass it via broadcast to another part of the application. In that case, in order to put extra and include our object, we would need to have it be parseable. There are four methods that one must include within a parseable class. They include write to parcel, and this method writes the state of a class attribute by attribute to the parcel using the should that be write methods. And then we have our constructor. This additional constructor reads the attributes from the parcel and recreates the original class or object. It's very important to note that the order of the readX and writeX methods within write to parcel and the constructor respectively must mirror one another. So let's take a look at this right here. You'll see here it's irrelevant, the type of class, but what we're doing is we're working with one that has essentially, so is it 1, 2, 3, 4, 5, 6, 7 attributes. The hash key, user ID, timestamp, session length, read status, user log, and message. You notice that the ordering up top must be the same as the ordering down below in order to ensure that when the stream is intercepted, whatever the first object that was put in is the first one pulled out. Second one put in is the second one pulled out. And we also have to match the types: string, 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 int, string, 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 int. If we don't match the types appropriately, what will happen is it will lead to a improper packing or unpacking of the information. Because essentially, when it's packed into a parcelable form, it loses any information about what the attributes were, what their names were, what types they were, and it's all, I assume, put into either some binary or hex. We also need a creator. This interface generates instances of the parseable class from a parcel, and then also describe contents. This is one that we can use to describe the contents contained within an instance of a parseable object. Almost any class may be adapted to use the parseable interface. I would assume there's some limits there, but I can't think of any off the top of my head. Now, to understand the rest of this code, there are several Android OS and Java objects that we must also understand. And we'll talk more about this later. The main two, again, this is now moving into the Bluetooth realm, the Bluetooth adapter and the Bluetooth device. So the Bluetooth adapter represents the local device, aka the Android OS device, the adapter of that device. And this object allows us to perform fundamental Bluetooth tasks, such as initiating device discovery, querying a list of bonded devices, etc. The Bluetooth device represents the remote or external Bluetooth device. It allows us to create a connection, query information, etc., etc. So our main objective here is going to be to foster communication back and forth between the adapter and the device, and then we already know that we are later going to want to pass that on to DynamoDB. Now that we've briefly introduced the idea of a Bluetooth adapter, a Bluetooth device, we're going to move forward to section C. There was a section B which talked a little bit more about the interaction between native code and React Native. Like I said, that's not going to be the main focus of this presentation, so I decided to skip that chunk. There's not too many parts where it connects to what we're going to discuss here, and if there is, we'll go back quickly and touch upon it. So the next thing that we want to do is to access the smartphone's Bluetooth radio or adapter and return the list of available Bluetooth devices to be displayed. We said in React Native, but we're just going to display it to the user. For that purpose, we will open up essentially a new project, which we'll start from scratch. So we're going to be doing this piece by piece, meaning that we're going to build up to the end of taking the actual characteristics and passing them to DynamoDB, but we are at this point far from that. So the first thing we need to do is at least see that a connection with a Bluetooth radio is possible. And so that's what we're talking about here, accessing the Bluetooth radio and just seeing what its UUID is. So now, the basics of Bluetooth in Android Studio are for Android OS. The Android platform includes support for the Bluetooth network stack, which allows a device to wirelessly exchange data with other Bluetooth devices. Various APIs allow an Android application to scan for other Bluetooth devices, query the local Bluetooth adapter for paired Bluetooth devices, establish various COM channels, connect with other devices through service discovery, transfer data, manage multiple connections, etc., etc. Ultimately, we are going to work with Bluetooth Low Energy. However, it makes sense to begin by investigating Bluetooth functionality overall. For anyone who's used a Bluetooth device before, they are familiar with pairing and bonding, right? A Bluetooth-enabled device, traditional Bluetooth, in order to transmit data, the two devices must first form a channel of communication using a pairing process. So this is like when you try to connect your Bluetooth headphones to your iPhone or to your Android phone, or you try to connect your phone to your car, right? That's a traditional Bluetooth connection, which requires pairing. Once the devices are paired, they must also complete a bonding process during which they exchange security keys. These keys may be stored for later use, meaning that previously bonded Bluetooth devices will begin communicating after pairing without the need to exchange new security information. You've had a car for a couple of months or years. As soon as you step into the car, your phone automatically connects. Note that pairing is a temporary process, whereas bonding is more permanent. So the first time we connect a device, we are going to pair and bond it. But the second time, or later times, hopefully, we will only need to pair because the bonding will already be complete. Now, Bluetooth permissions. We talked a little bit about generic permissions before. Now let's talk about specific Bluetooth permissions. To use Bluetooth features within our application, we must declare two different permissions. Actually, there's three, but only two are dangerous. So there's Bluetooth, which simply provides the application access to the Bluetooth radio. There's the access, I put access find location, but actually we can use access course location instead, and that's what we're going to use. So because a Bluetooth scan will inherently gather information about the location of the user, whether that information is desirable or not, for newer versions of Android OS, we need to request the access course location permission in order to use the Bluetooth radio. Then there's also permission Bluetooth admin, which allows the app to initiate this device discovery and manipulate Bluetooth settings. This second one is the one that is going to, I don't want to say be the most problematic, but is going to be the one that is going to take up more of our time. So the next question is, how do we grant these permissions? Now we're talking about this in a more specific manner, specifically for Bluetooth. The answer to this question is covered in the previous section. Actually, we already discussed this. I apologize. We showed the specific code that was required in order to get the permission for the access course location. Okay, and when we get to more complete, more built up examples, what we'll do is we'll briefly take a look at those permissions again. Now, We want to see what devices are available. Therefore, we need to initiate a device discovery. Device discovery is the is the method or the procedure that searches the local area for Bluetooth-enabled devices and requests some information about each one. A nearby Bluetooth device responds to a discovery request only if it's currently accepting such requests by being discoverable. Again, that's another term we're all familiar with from using our Bluetooth headphones and stuff like that. If a device is discoverable, it may provide information such as its name, class, and unique MAC address. Now, BLE, Bluetooth Low Energy versus traditional Bluetooth. This project or this tutorial requires us to use Bluetooth Low Energy. That was our goal initially anyway, as opposed to traditional Bluetooth. And there's several reasons for that. A lot of my work personally is in the area of Internet of Things, and a lot of times for Internet of Things based devices, we're more interested in sending updates with relatively low bandwidth, data rates, and saving energy as compared to the opposite, which is using whatever energy it takes in order to transmit high fidelity data, such as an MP3 audio or something like that. Okay, so we should discuss the differences before we get too much further into code functionality. These were a couple tips I put in here. I don't think we really need to talk about this. There's more reminders for myself. So the architecture, Bluetooth Low Energy is a version of Bluetooth which is optimized for designs where reduced power consumption and lower data rates / bandwidths are emphasized. Unlike standard Bluetooth, which is based on an asynchronous serial connection, UART, the BLE connection acts more like a public bulletin board. A number of devices may share the Bluetooth Low Energy connection, posting messages to the board and reading messages posted by others. I think this source actually gives a really good picture. Let me see if it'll open up. So this is the bulletin board example that they used. So not to skip too far ahead, but we can have several central devices or clients connecting with a peripheral device or a server. That peripheral device will define different services, and each service will have different characteristics. So you can imagine these characteristics as just being post-it notes. It may have what the temperature is outside or what the state of a given machine is. And so depending on what permissions are given, potentially any central device can pull off a post-it note and replace it with another updating the value. Sometimes they may not have permission to write, which means they can only read the value. But anyway, it's an asynchronous, very general process that allows different parties to read and write whenever they want to, and this is what allows us to save energy. So each radio acts as either a peripheral, this is the bulletin board device, and it's kind of like a server. So this device posts data for all other radios to read. Then we have central or reader devices. They sort of operate like clients. And so this device may read the data posted by a peripheral device. Now, it may also write and make changes in certain cases, depending on what permissions are or what access is defined by the peripheral device for a given service or characteristic. The information presented by a peripheral is structured as services, which is then subdivided into characteristics. A service is a notice, and a characteristic is a paragraph. Anyway, that's an analogy they use. Okay. Bluetooth Low Energy supports a mechanism known as Notify to inform central devices that data from a service has changed. When Notify is enabled for a characteristic, updated values are automatically pushed to the desired receiver without that receiver making an actual request. Bluetooth Low Energy also supports a mechanism known as Indicate, for which only an acknowledgement is sent, not the updated value themselves, which can save some bandwidth and energy. The client-server structure is generally called a publish and subscribe model. There are 4 things that a central device, aka client, can do with a characteristic: read, write, or indicate / notify. And we talked about what those are already. A characteristic can have a value with up to a length of 512 bytes, although I have seen variances in that value depending on what hardware and what software you're using. I think that is a theoretical maximum for the protocol. Moving on, a Bluetooth peripheral, like an Arduino Nano or something else, will provide services with associated characteristics. We've talked about that already. We may define our own service or use one that is standardized by Bluetooth. Each service is associated with a universally unique ID, UUID, ranging from 16 to 128 bits in length, and anything longer than the maximum won't be displayed in the general advertising profile, which is called the gap. Bluetooth devices let others know they exist by advertising their gap, their general advertising profile. Advertising packets can contain a device name as well as a list of services that it provides. However, gaps have a limited length. Not all services must be advertised because a central device, aka client, may also learn about other services during the connection or bonding process. Non-advertised services, however, cannot be used for discovery. The general attribute profile, which strangely still has the acronym, would look like GAP again, but we call this one GATT, GATT, is a layer that defines services, their characteristics, as well as enables read, write, notify, and indicate operations for them. We will begin our investigation, or what we're looking at here, into creating an application that establishes a Bluetooth connection with an Arduino Nano using the battery level monitor tutorial that's available here. I'm going to click on that link. And before we jump into the firmware, we must install Arduino Ble.h. This is the library we need using the IDE, Arduino IDE library manager. So this is a really good example to start with. Apologize for the edit there. That page didn't want to seem to load, but the battery level monitor is one of the really the most basic examples that Arduino uses to demonstrate how Bluetooth low energy can be used with their hardware. It's embedded within, or it's available within the IDE. I think it's one of the basic examples that comes with the IDE. And there's lots of really great websites that talk about how you can implement it. Okay, so couple things. I encourage you to take a look at that battery monitor. We will come back to it. But before we do that, the next thing I want to talk about is how we can test the Arduino's Bluetooth by itself. Because it's going to be hard enough to try to debug an Android application, as well as the cloud aspects of it, as well as the firmware for the Arduino, all at once. And so we're going to want to split that up. We're going to want to use a device which allows us to test just the Arduino code without the Android. And so for that, we can use, there's a whole bunch of really great applications. There's Bluetooth Terminal and RF Connect, which is made by Nordic. And so any of these will allow us to access a device and, with a pre-made interface, look at what services are being offered, what the characteristics are that are within those services. Okay, so we're going to test our connection. We're going to follow these steps. We're going to upload the battery example. So we're going to take the example code provided by Arduino, which is available for download here. Let's see if this link works. Oh, this is one of my links. Anyway, it's available within the Arduino IDE. And so the example code configures the Arduino Nano as a Gatt server, general attribute server, providing a single service with a single characteristic, and that service/characteristic is the battery level of the Arduino. Actually, let's take a look at this real quickly. So I'm just going to hit the highlights. Again, this is not my example. This is directly from Arduino. So we create our service. We create a single characteristic associated with that service. We define the old battery level. We begin a serial interface. Sorry, don't mean to do that. We set the pin mode for the built-in LED, which will allow us to flash it when the device is connected. And then down here, you can see where we set the device name, the advertised service, we add the characteristic, and we add the service. So, and then we begin advertising. I'm not going to spend too much time going through this code, only because we are going to do a more in-depth example later on. So I don't want to get too far ahead. Again, I recommend you download that example and try it out yourself. Next, we're going to download the Bluetooth terminal. I use both of these. Both have their pros and cons. It's a little bit easier to write characteristics with one. It's a little bit easier to read with the other. Applications are very easy to use. When they find the device they are looking for and begin to monitor data from any available services. In this case, we're just going to be looking at the battery level. And so if you look, the characteristic is named within the firmware 2alpha19, and so we see 2alpha19 coming through. All right, so this should be a relatively easy task for us to complete, especially since the code was given to us. One thing to be careful of, this tripped me up a little bit, is the command while not equal, while the serial connection is not active. You may need to delete that from the setup because it will prevent the Bluetooth connection from initializing until one starts the serial monitor. And if you're not having, if your microcontroller is not connected to a computer and just to a general power source, then that may be problematic. Next, we try adding a second test characteristic to the service as shown in this code here. So let's take a quick look where we added a second characteristic. And so that's just right here. Right, we added a second characteristic called characteristic 2. And it pretty much mirrors how we create and add the first characteristic to the service. And anyway, it shoots out a constant value of 99. So you can see here when we used our monitoring terminal again, now you'll see two different values listed. The second one, which we added, and then the battery level, which was initially there. Okay, so now connecting to a Bluetooth low energy device. So far, we've learned about how to interface Android OS native code with a traditional Bluetooth connection. However, from this point forward, we will shift our focus to Bluetooth low energy connections, which, as discussed above, have their own specific architecture. This is when we talked about the bulletin board, the services, the characteristics. Fortunately, everything we learned about scanning for discoverable Bluetooth devices above works the same for traditional and low energy Bluetooth devices. Strangely, some of the documentation says that there's a separate method you have to use to check for a Bluetooth LE. I did not find that to be the case. All I had to do was put a filter or an if-else statement that checked whether the device was Bluetooth LE, and you'll see that in the code. So server, client, and socket overview. Before we jump into this section, it's important to quickly talk about network sockets and what they mean. Again, this is more review. You can skip forward if this is still something that you're very knowledgeable on. So a network socket is an internal endpoint for sending or receiving data within a node or computer network. It is a representation of this endpoint in networking software, such as an entry in a table. It's a form of a system resource. The term socket is analogous to physical female connectors, where one may imagine that two sockets are connected by a cable with two male connectors. That's where the name comes from. Note that the term network port is used for external endpoints at the node, while socket refers to internal endpoints. In order to create a connection between two Bluetooth devices, we must implement both the required server and client-side mechanisms. One device must open the server socket, and the other must initiate a connection using the server device's MAC address. So we are going to have our Arduino acting as the server, and our other device is going to be the Android OS. The server and client obtain the required Bluetooth socket in different ways. Server receives socket information when an incoming connection is accepted. Client provides socket information when it opens a channel to the server. The server and client are considered connected to one another when they have connected Bluetooth socket on the same COM channel. At this point, data transfer can begin. One way to establish the connection, which we're going to go into later on, is to prepare both devices as servers such that each is listening for connections with an open socket. This provides maximum flexibility because either device can initiate a connection with the other, turning from server to client. This may be overkill for our application, and we're not going to do that. We are going to learn how to connect an Android device as a client to a Bluetooth generic attribute server, Gatt server, which is again going to be on the Arduino. Okay, specifically, we are trying to connect our Android OS application with a device like the Arduino. Therefore, we must define a firmware that makes the device discoverable with a unique name. So we're going to use this name, DEIS2020 device, and actually this prefix is what we're going to use in order to tell whether what device it is to which we want to connect. Now, there's other ways of doing this. You don't have to have a prefix. You could have the user select, but this just makes it easier. So the way we will prove that a viable Bluetooth LE connection has been made is by our ability to access from that radio the list of services that it offers. We are currently trying to connect an Arduino Nano that offers a single service, the battery monitor, with two characteristics. One is the battery level. The second is a dummy variable that we added, the one with the -99 constant. Note that the service is represented by UUID 180F, which is standard for battery-related services. So let's take a step back and look at how we connect to a Gatt server. Some of this is repetition. So first, we check whether Bluetooth LE is supported. We determine Bluetooth LE functionality by creating and initializing a Bluetooth manager from which a Bluetooth adapter is extracted. Then we check if the Bluetooth adapter is equal to null or Bluetooth adapter is enabled is equal to true. We need for this to not be true. We want it to not be null, and we do want for this to be true in order to progress further. We need to enable BLE if it's disabled. For that, we'll create an activity that asks the user to enable the Bluetooth connectivity from an intent with an associated action. And this is great because it's provided by the API Bluetooth action request enable. We'll then scan for Bluetooth devices. We'll talk about the scanning method in a second. There were several that I found online. We're going to be using the one that's the newest version. And once we find our device, we're going to do that now based on the prefix of the device's name. So it's going to be searching for a device with the prefix of DEIS2020. And then lastly, we're going to connect to the Gatt server. And this is the part of the process we have not yet addressed, and we will discuss in the below. So let's take a quick look at the code. And so what you can see here is, I mean, it's really hard to go into the details of the code, as you can tell. Right, we create our broadcast receivers. We perform our permission checking. We check whether Bluetooth LE is supported. We determine the functionality. We enable the Bluetooth. If Bluetooth is disabled, we ask the user to enable it. And if the Bluetooth is enabled, we scan for devices using the, where is it? Adapter BT start discovery. You'll see above it, we have this handler and Runnable with a post-delayed timeout. And so what we're saying is that after 5 seconds, it will stop. You'll see cancel discovery about 3/4 of the way down the screen. So after 5 seconds, it'll cancel discovery and then try to connect to the device. And this is what we have not done yet. So the next step in here is to try to connect to the Gatt server. And so this is a visual representation of how the code looks right now. Sorry, I don't know why this won't zoom in. So we have our constructor, which creates a list of Bluetooth devices. We're going to actually change that later. We register our receiver, which will tell when a device is found. our method creates another broadcast receiver, which will then add the device that's found to this list devices BT once it's found. We do our permission checking, we determine Bluetooth functionality. If the Bluetooth is disabled, we ask the user to enable. If the Bluetooth is enabled, we start discovering, and then we return the target device using a custom function that we've developed. Okay, so this will become more clear as we get further and further into looking at actual code. So creating a Bluetooth LE service. Things will get a bit confusing here as we need to create a bound service with the following components. Now, right now, we're creating a bound service because we're running this off of an activity. We're creating an app that has a UI. Later on, we're going to change this to use a service only. In that case, it will no longer be a bound service. It'll be one that's on start. Okay. And so we have our local binder definition and instance. We need to define a local binder class that extends the binder and contains the method getService, which returns the service to the activity. We also need to define an instance of that local binder, which we'll call mLocalBinder. Together, these objects will allow us to define an instance of a custom service where the main activity is shown as below. And so you can see here, instance of a local binder, and that simply is just an I binder, which is of the type new local binder. This local binder we define down here. It extends the superclass binder, and all it does is return our service to the main activity. Over here, you can see some code from the main activity, which says on service connected. Okay, this is going to be part of the callback function that is called when we start the connection. And so this response will be triggered once the service is connected, which is essentially just going to be getting the service. And again, giving us this M service Ble005, which then we can perform actions on. So in addition to that, there's the onBind method, which determines the service's response to the bind request, the bind service request, and that is shown here. So on the left-hand side, we have the code from the service. Again, it onBind returns the mlocal binder, and over here we have from the activity, we can see that we create an intent with the service Bluetooth LE005 class, and then we bind the service as shown here. We also need a public connect method. The connect method is public. It's the only one accessible to the main activity aside from getService. This service is designed such that the main activity calls connect and other steps automatically occur. So this is sort of the entry point to our code. This method is very important because it applies the connect Gatt method from the Android API to the target Bluetooth device, which we're going to call device in. And this generates an instance of Bluetooth Gatt called mBluetooth Gatt, which represents the Gatt server throughout this service. Once we have access to the mBluetooth Gatt to that server, we can start doing a lot more actions with it. As you can see here, once we have access to so this method is the connect method. It passes in the device to which we want to connect. This code is just for commenting, but the main thing here is we use device in.connectGatt, and that creates our mBluetooth Gatt server. We also need to pass to it a callback function, which will determine what happens as certain actions are taken. On the activity side, we'll see that we have our M service Ble005. This is our Bluetooth service, and we connect and we input the device for connection that we have isolated based on its prefix. We're going to use a broadcast method. So service Bluetooth LE cannot communicate with the activity directly. We could have used a listener, we didn't. But here, for that purpose, we generate a generic broadcast receiver or a broadcast Broadcast receiver in the main activity, listening for broadcast with the action temp 000. So this right here, you don't need this. It was just a general broadcast receiver I set up if I wanted to send any message back to the main UI in order to have it displayed. Then we have our Bluetooth Gatt callback method. This is very important. So as I said right here, when we have our device in .connectGatt, we need to define a callback method, which then determines what happens after that point upon the connection. The connectGatt method referenced above requires a Bluetooth Gatt callback input to define what happens upon connection. This abstract class, similar to an interface, contains member functions such as onConnectionStateChange, onServicesDiscovered, which, as their names imply, define how the service responds to certain changes. This method is private and never accessed by the main activity. And so you can see here on ConnectionStateChange, it essentially just communicates a message back to the activity saying that a state change is detected. So the code for the service may be downloaded here. So let's take a look at it really quickly. Okay, so this is the service. I'm not going to go through it line by line, but you can see we initialize our Bluetooth Gatt. We also initialize the Bluetooth Manager, the Bluetooth adapter. We discussed those earlier. We also set up some bit masks to define the connection states, disconnected, connected, etc. And then we move on to the local binder definition and instance. So we've gone through a lot of this already. We create our mlocal binder, and then we define the local binder method, which extends type binder and again returns our service. Now the reason why we can use a local binder is because we're not communicating with an external party. So if we're communicating within our project, the local binder is sufficient. So we have our onBind method. We have an onStart command, which is not needed here, but we will need it later. Our public methods primarily is the connect method, and you'll see that this actually calls the connectGatt method and then leads us to our callback function. The callback function is down here. It has several internal methods on connection state change. So on connection state change, you can see that if the state is connected, what we'll do is begin to discover services right here, halfway through the page. If it's not connected, then we are going to have to tell the user that they need to connect again, perhaps manually. We also have the on services discovered. And so what this does is it takes the service and adds it to this list Gatt services that we're creating. We're trying to create a list of all the services and then later all the characteristics that our device offers. Okay, so as the heading above suggests, the next step is to connect our Android application to the Bluetooth Ble Gatt server as a client whose behavior is determined by the Bluetooth service discussed above. This is performed in several steps. We define the service instance, which will be used throughout the module. So service Bluetooth Ble, this is the name of our service. We give it an instance name. And then we also have this Boolean variable mBound, which tells us whether it's bound or not. And then we're going to bind the service to the activity using this code right here. So you don't need get React application context because we're not doing this in React. You can just use this, or you can say get application context, bind service, pass the appropriate intent, which has the service name in it, and then we can go from there. We're also again going to define some broadcast receivers, which are going to one is general, the temp 000, and then we have one for action Bluetooth found, which we've already talked about that. That handles when a Bluetooth device is found. We define a service connection instance, which provides the main activity with access to the server, and then call the connect method from the service. And then the service really handles the rest. So in the main activity, all we have to do is bind the service, and then really just call the connect method. And then from there, the service handles everything else. And you can see the code is provided right here. In the end, this code provides us confirmation that we have connected to the service 180F as shown in figure 26 below. And it's a little bit hard to see, but the last one says Bluetooth LE has connected to Gatt server as well as retrieved at least one service. Okay, so now let's move on to some intermediate Bluetooth and I'm going to say not React examples, just Bluetooth and Android examples. Now that we have the basics of Bluetooth working as an Android OS native code, as an app, we can raise the bar slowly. All of these examples will help us do that. So the first thing we're going to do is to try to write a BLE byte characteristic. So let's design Arduino firmware with one service and two characteristics. MBLE char byte 2, so this is a Bluetooth character of type byte, and it may be read or written to by a client or central device. And then we have a float type characteristic, and it may be read only by the central device. The characteristics will be displayed to the user via serial monitor from the Arduino, as well as brightness in the built-in LED. Unfortunately, you won't be able to see that, but the code we can see is available here. So this is the firmware for the Arduino at this point. Going from top to bottom, we define our service, which is called 0001. We have our two characteristics, 0002, 0003. We begin the serial connection, we initialize everything, we set the device name, the local name, we set the advertised service, we add the characteristics to the service, and then we add the service to the device. We write values to both the characteristics, and then we begin advertising. And if we want to, we can again initialize or reinitialize those values using the write value method. Okay. Now in our loop, the first thing we're going to do is wait for a Bluetooth central device known as the client. So we essentially set up a variable that can store that. And we say if this device, MBLE device central, is not null, okay, meaning connection has been established, then we jump into this part of the code. So while the Bluetooth central device is connected, what we're going to do is read the characteristics and print them to the user. Again, this is a really simple example. Then we can write the updated value to our characteristic. This is for characteristic number 3. And so you can see MBLE char float 003 dot write value, and then we include our new value, and that will be posted to the Bluetooth bulletin board or to the server. Okay, next, writing a Ble Int characteristic. So next, let's design a similar firmware, which again has one service and two characteristics. The difference here being we're going to work with an int. Again, it can be read or written. And the main difference between this example and the last is the need to transfer more than one byte between the central and peripheral device, specifically 2 bytes for an int type variable. So depending on the type of characteristic it is, that will determine the length of each chunk of communication that you send. So the code for this example may be downloaded here. We'll take a look at it in a second. But figure 46 shows the hardware working as expected, accepting a value of A1B2 from the NRF mobile application, which is shown down here. You can see I entered it into the screen, and then I hit write. And over here, you can see it being reflected by the serial monitor of the Arduino and being written to that characteristic, and that's being picked up. So we can take a quick look at the code. I don't know if there's going to be too much interesting here as compared to the previous one. I don't think so. It's pretty much exactly the same. We obviously had to change the type of characteristic. Everything else is the same, more or less. So not too much more to take away from here. Now, to go down to the bottom, you may need a function that converts byte arrays into integers, and this will help you in certain cases where the data is coming in as a byte array and you want to display it as an integer. We'll talk about that a little bit more later on and when that may or may not be needed. Now let's try writing a Ble double characteristic. In the end, all the data transferred between the client and the central device and the Gatt server is sent in bytes. As such, we can use Ble Int Characteristic to receive float type variables as long as we interpret the data properly. The most important differences between Ble characteristics are the respective maximum transfer units as shown in this table 1 down here. And so this tells you the maximum number of bytes that are transferred for each type. If we want to send as much data as possible in a single packet, then we'll use Ble double type characteristic. So let's adapt our example above to accept a Ble double characteristic, which allows a maximum packet transfer of 8 bytes. And if we look at the code here, again, not too many changes. All we have to do is change, if you look in the middle of the screen, we change the characteristic type and define it, well, where is it? Up here as a Ble double characteristic. I would go through that code in more detail, but it's a lot of the same. Okay, now we have gotten pretty good at designing our firmware, at least on a, let's say, elementary level. And we have gotten pretty good with writing to it and reading from it using one of the terminal devices, like the NRF, or what is it, the other one, I forgot the name of it. So now let's move on to writing a Ble double characteristic via Android. So for these examples immediately above, we've been relying on mobile apps like NRF Connect and Bluetooth Scanner tool to communicate with the Arduino Nano via Bluetooth low energy. However, now we want to move back over to Android, and our goal here is to adapt the code from before such that it reads and writes to the Ble characteristics within the Arduino firmware. So if we look back real quick, we begin with the code version that we looked at previously. Right now, the application can discover the available Bluetooth devices, connect with the appropriate device, and access that device's Gatt server. It can also display all available services to the user. Again, you see them listed here, showing that there's 2 different characteristics present for that service. Now, we need to understand the characteristic properties. So we updated the code a bit to give us information, including output from the following methods applied to the characteristic in question. Get permissions returns int. Unfortunately, it seems like this method always returns 0 for Android devices. I looked online a little bit to get some more detail on that, and it wasn't 100% clear. I did not use that. I just, essentially, because I created the firmware and created the Android code, I knew what permissions each one had. Get properties. This command returns an integer that is more appropriately interpreted as a bit mask, where each bit represents, okay, so we have bit 1, 2, 3, 4, 5. Property read, which is 1 when it can be read, the characteristic. Property write no response, which is 1 when as the name suggests, the characteristic may be written without requiring a response from the peripheral. Property write equals 1 when the characteristic may be written, but potentially a response is required. I have not used this. I have always gone with the no response. I actually have another method of doing the handshake. I write it to another characteristic instead. And so right here, you can see this is the easiest way to compare the bit mask to a flag. And you can say mask properties and then the Bluetooth characteristic, your property you're concerned with, and see if it equals the one that is desired. So if what this says is if the bit number 1, which is associated with property read from mask properties, equals the Bluetooth Gatt characteristic property read, then yes, we have the right to read, and then we would go ahead and call the read characteristic from the Bluetooth Gatt. Okay, get value returns a byte array. This returns the value stored for the characteristic by Android. This method should not be confused with Bluetooth Gatt read characteristic, which actually reads the Bluetooth server. So there's 2 different steps in getting the value. We need to read the characteristic, which then just brings it into the buffer, and then we need to get the value, which will actually return the newest version of that value. So this is going to give us something that we can use. We also have get write type, and this returns a bit mask, similar structure, write type no response, write type default, write type sign, etc. Figure 50 displays the permissions, properties, and write types for both characteristics defined within the Arduino firmware. And so you can see here, it displays those permissions, or those properties, sorry. And so characteristic 002 returns true for property write no response and property read as expected. If we look down here, a property write no response, that's good. And 003 returns, we'll see here, returns property notify and property read again as expected. So I don't think that's on this screen. This table provides a more in-depth explanation as to how figure 50 may be interpreted. So let's take a look at this real quick. So if we look here, I just made this table up, and it shows both the service is the same for both. We have the characteristic names, we have the UUIDs, which is the short and the long versions. We have the get permission and the get property. So this is what you get as an integer if you just pull that value by itself. However, that's not very meaningful because it's a bit mask, so we need to pull out the individual bits in order to determine what's going on. So for Bluetooth characteristic 002, you can see that property write no response and property read are both given a value of 1. The other two we don't care about. For Bluetooth character float 003, the property notify is active and the property read is active. And so this makes sense given how we set up those characteristics. We can also see over here a discussion of the write types that are given, and that's shown in yellow. So you do have to understand that the integers spit out by the get permissions and get properties methods cannot be used by themselves, right? That number 16, 8, that doesn't really say anything. You have to pull out the individual bits in order to get anything meaningful from it. Next, we check for write capability. The next question is how these permissions, properties, and write types may be used to check for write capability within our Android app. Essentially, we only need to look at property bits 1 and 2, which correspond to property write no response and property write. If either, not necessarily both of those are true, then we have write capability. This code shows exactly how that may be done. All right, a little bit dense here, but I think you can pull out the proper pieces of code. We can see here about a third of the way down, characteristic K001, get properties, and Bluetooth Gatt characteristic property write, or Bluetooth characteristic property write no response. If it's not equal to 0, then we can write. So that's the most important thing to pull out of here, and we do something similar in the second half where we check for the type of write that is allowed to us. So now, finally, we have a spot in the code where we can properly write a value to a characteristic. Fortunately, this process seems to be relatively easy, where essentially we create a byte array with data. We set value to the characteristic using that byte array as the input. We set the write type. This may or may not be necessary. The default may work, but I always set it. And then we write the characteristic, which actually performs the write operation. So it's a little bit the opposite of how read works. For read, we read the characteristic, then we get the value. For writing, we set the value, and then we write the characteristic, because get value and set value, all they do is interact with the local storage of the characteristic. If we want to do any updating to the device itself, we have to use read characteristic or write characteristic. So the code is shown below. and you can see here, pretty straightforward. We create a byte array, we set the value, we set the right type, and then we go ahead and write the characteristic. Now this, you'll see in the code, will lead us to a function within the callback, which will handle what happens when a write is executed. It'll check to see if it succeeded or not, and if it did, then it'll perform certain actions. Now, managing the Bluetooth low energy Arduino with sleep mode. Most projects, especially for Internet of Things, you're going to want to have some ability to put the device into sleep mode and still be able to relay information. So we've talked about interfacing our Android app with a basic Arduino firmware that had no practical objective except to transmit simple values. The design of this firmware will become more complicated as we consider the need to perform other tasks, like do some real work, and potentially put the device in sleep to conserve power. For example, we handle sleep within the loop as follows. First thing we do, obviously, we wake from sleep. Then we begin advertising by calling the ble.advertise command. We perform whatever tasks that we need to be doing, whether that's some analysis, reading values from sensors, whatever. Then we try to connect to the client for a certain number of seconds. Once the primary task is complete, we'll give the Arduino another 30 seconds or so to establish a Bluetooth connection and update characteristics before going to sleep. Theoretically, the Bluetooth connection can work in parallel with the primary task, meaning that time duration could be very short and perhaps even 0. And then after that's done, we stop advertising in sleep. Now, in later versions, we're going to add an additional step in here, which is going to be the handshake. And so instead of relying solely on a timeout, we are going to have the Android device write a characteristic back to our Arduino and change the state from 0 to 1, meaning that it's been read. And so the loop will read that the state that the characteristic has been read by the state, and then it can go to sleep early, which is good for saving energy. This is just one way to manage Bluetooth low energy for Arduino with sleep mode functionality. And we can go into more detail using this firmware as an example. So let's take a look here. All right. So the main interesting part here, so we have our Bluetooth service. We added 4 or 5 characteristics. This is not important. This is something else associated with the project. Okay, so I scroll past all this stuff. And we get to the setup. The setup's relatively simple. We define the pins, the analog write resolution, all that type of good stuff. Obviously, we have to define the Bluetooth configuration. Again, device name, local name. We add we set the advertised service. We add the characteristics, and then we write initial values to the characteristics. Now, inside the loop. Okay, so whenever the device wakes from sleep, it will jump straight into the loop. So the first thing we're going to do is begin advertising the Bluetooth connection. And we are going to start this middle part here under generate the signal. This is where we're going to be doing the work that the Arduino needs to perform, which it could be something else depending on what your application is. Then we're going to calculate the time passed. This is essentially the value we want to transmit back. We want to transmit back how long it took the Arduino to do this task. So we write that value to one of the Bluetooth characteristics, and we connect for XX seconds. So I use this for loop here in order to wait for a connection. So if you say if MBLE device central, that means if that's not null, it's connected. It will write all the characteristics such that the central device can read it. After the delay is over, it'll stop advertising and it'll go to sleep, low power .sleep. The waking from sleep method is very simple. It just flashes the LED a couple times and then jumps straight into the loop. So initial configuration. As part of the firmware, outside of both the setup and loop methods, we will need to define the BLE service and characteristics, we already know how to do this. Define the pin assignments, we already know how to do this. And define the signals or whatever work we need to do. Pin wake up is an important one. If we're going to be using sleep, the generally best way to wake from sleep is to use a wake up pin. That way, the user can push something and then actually activate the device and bring it out of asleep. And if you go back to that previous code we just showed, you'll see that we did define a wake up pin. Okay, so setup methods here. I don't think there's too much new, right? We define the pin nodes, we assign a wake up pin, we define the Bluetooth configuration, and then we run the loop. So a lot of everything above here we already sort of explained in the code. Okay, so now we've gotten to the point where we're communicating with the Bluetooth LE device. We're bringing it into into Android OS. I don't think we've shown detailed code there, but in here we'll get more into that. And the next step is to upload that information to DynamoDB. So we're going to take a big step forward here. We're going to put together a lot of the skills we've learned in this document, as well as prior, to build an Android OS application that achieves the following tasks. Acquires data from the Arduino via Bluetooth, specifically the length of time in milliseconds that it took for the Arduino to complete its last task. We tag it with a timestamp, and we save that data to AWS DynamoDB such that it may be accessed by a third party later. Let's say you want to build a web app that accesses this information and is able to get whatever information from its users. Our goal in turn is going to be to turn this application into an auto start service that is always running on the Android OS device after boot. We're going to discuss that a little bit later, though. So, a lot of background in this presentation. I think it's great for those of you that are becoming more familiar with building these types of projects. Again, if you not what you need, you can fast forward. So let's start this project from scratch, a completely new Android Studio project for which we will pull code from previous things that we've done. Don't forget to properly set the minimum SDK based on the device we will use for testing. Our device relies on Android 7.0, which means that our minimum SDK will be 24, API 24. Next, we add our permissions. So this is a great starting point if you're building the project from scratch, because it shows you everything that you need to do in order to get this project off the ground. So next, we add the permissions for internet, for Bluetooth admin, and for accessing course location. We've talked about these before. They have to be included in the Android manifest.xml document as uses permission. Now, like I said, this doesn't automatically grant us the permission to access course location. That is considered a dangerous request, and so the user will have to approve that. Okay, so now let's recreate our Bluetooth service. In section D above, we spent significant time learning how to interface an Android OS device with an Arduino using Ble, and we're going to use a huge chunk of that code again here, and this time we'll go into more detail about the code. However, we do need to revise how this service works. So the input, the output, and the objective. The main objective of this service is to read all the values from the Bluetooth characteristics and save them to a JSON array named mJSONArrayMaster. That is actually going to change later. We're going to build a custom class for this. This document was a method of me learning how to do this, and so at certain points I switched things up as I discovered more efficient ways of doing it. So the input, the parent activity provides the service a single input, a Bluetooth device which serves as its target, and the output is the master JSON, which, as you can see here, will be structured to provide the UUIDs, the array of characteristics, including their values, and their status. This is just a sample structure of how we could set this up. Now getting into some more interesting parts, let's talk about how this service will work. The parent activity has access to one public method, which we renamed to read all characteristics, because that's what it's going to do. We start the service and it's just going to read all the characteristics. And it accepts a single input of type, again, Bluetooth device. The method applies connect Gatt to device in to create a Bluetooth Gatt object named mBluetooth Gatt. So we use the device to create the Gatt server. What happens after connect Gatt is called is defined within the callback function, which we talked about previously. The callback function starts an iterative process where the service listens for active Bluetooth connections, discovers all services associated with that connection, cycles through every available service and characteristic, reading values from the hardware when possible. The best way to understand this service is to read the commented code as well as this flowchart right here. Okay, and I think I have a better version of that. Let me see what this is. 610. I think I have a better version of that over here. Okay, so what we can see is that we have our class variables, the Bluetooth Gatt, the list of services, a matrix containing the characteristics themselves. This will be a matrix because, right, we'll have multiple characteristics as well as multiple services. We have our JSON array master, which is going to be what we intend to return, everything in one succinct location. And then we have the indices for the service and the characteristic. And so we're going to use this to increment through the services and through the characteristics. We, again, a lot of repetition here. We create our local binder, and that calls, we create our local binder class, which is then used by the iBinder and returns the service to the main application. We have our onBind method, which again just returns the local binder. And then now we get down to the meat of this. So we have a public function called readAllCharacteristics, which accepts the device coming in. All right. And all it does essentially is just call the connect Gatt method. And that is past a callback, which is shown here. And the callback method has all these internal methods. On connection state change, if the new state in is connected, then we can begin to discover services using the command below. mBluetooth Gatt .discover services. That, once that's started, that will refer to another part of the callback, which is on discovered services. And so we're going to cycle through, assuming that the status tells us that it was properly discovered, that it was a valid response. We'll cycle through all the elements of the Bluetooth Gatt get services and add them to our mGatt service list. Then we're going to cycle through all the characteristics for each service and add them to the mGatt characteristic matrix. So in the end, we're going to have a list of all the services as well as a matrix containing all the characteristics, and all this is done by reference. So you can essentially pull the characteristics as that object out of the what you call it, the array lists. Then we're going to build the JSON to store the services, and this is really just a conversion of the mGatt char matrix into a JSON form. When we get to the code, we can look a little bit at how that is done. But this is really just setting up the general structure. Right? There's no values in here yet. This is the structure, and now we have to populate it. Next thing, we're going to begin read operations, and so we apply the read characteristic, and we get our first characteristic from the matrix. And again, which characteristic we're looking at will be determined by these two right here, the service and the characteristic indices. So you see that's going to be passed in right here. That read characteristic then we'll call the onReadCharacteristic method. It will pass in the characteristic that we're concerned with as well as the status. We check if the read status was successful. If it equals Gatt success, we use get XYZ, whatever the appropriate characteristic name. We use those methods to pull the values from characteristic in and transfer them to the JSON document. And for that, we're going to use a custom method called update JSON master array, which is below. So the way that this works is we read a characteristic, then we call read next characteristic, which is a private method. All that does is increment both the indices and then load the next characteristic. And if the characteristic can be read, it will call read characteristic and Bluetooth Gatt read characteristic and lead us right back up top, which again, it'll read, see if there's success, then read next characteristic, increment the indices, see if we can read, loop back around. And so this is part of the loop that will really drive the service and the way that it works. It'll bounce back and forth between on read characteristic and read next characteristic. We can take a look at the code really quickly. I mean, again, there's sort of limited benefit from looking at the code, I think. You can see here the service. We define the Bluetooth Gatt. We initialize the record of all the services and the characteristics. We also initialize the JSON array. We initialize our indices. We define some of the bit masks. We do all the local binder stuff, which we've talked about a million times. And then now we have our read all characteristics public method. Like I said before, it just connects to the Gatt and then forwards the code to the callback function. And here we define the on connection state change. If the state is connected, then it begins to discover services. If it's not connected, then it's going to ask the user to connect. Then we have on services discovered. So if a service is discovered successfully, then what we're going to do is add it to our mgat service list and mgat characteristic matrix. And that's done by just using the basic add method associated with any list or any matrix. Then we build the JSON object to store the services. This, I'm not going to go too much into detail. Really, you can build this in any way that you want to, depending on how much information you want to pass back and what you want to keep and what you want to lose. I actually went back later on and significantly simplified this because it was just giving way too much data back to the main application. It was really hard to sort out. And then we have on characteristic read. So once it reads a characteristic, it tests to see whether the transaction was successful. If the value is not null, then it will update and add the value to the JSON array. So actually, I take that back. If the value is null, then it'll save a null value to the JSON array. If it's not null, which is what this else statement is telling us, then we extract the characteristic using this statement. So characteristic in dot get int value, and then what we have to do is set the format that we want. So Bluetooth Gatt characteristic dot format unsigned integer 16 is what I'm using with an offset of 0, and that passes us back the integer. And that is what we can use to update the JSON object. We talked about the read next characteristic method that's shown here. Again, we update the indices. We check to see if we've reached the end. So if we reach the end of the maximum number of services and characteristics, then we stop, return 0, and that exits the recursive loop. If not, then we read this characteristic. We get the permissions and properties, make sure that we have permission to read it. If we do, we read the characteristic. If we don't, then what we do is just simply move on to reading the next characteristic. So there is a recursive function call inside of this read next characteristic method. If the characteristic coming in cannot be read, it will just automatically move on to the next. This method here is the one we use to update the JSON array. You can take a look at it if you want, but again, I suggest you probably build something on your own to do that. Now that we've talked about how to structure the service, we need to discuss the main activity that calls the service and actually pulls the values and displays it to the user. Now, we're going to take a look at this flowchart right here, again, as a way to demonstrate how I've structured this. Then we'll take a look at the code. So the activity has several different class variables, one of which is the service itself, which needs to be called in the proper manner. A Boolean variable, which determines whether the service has been bound or not. And then, as we've seen in previous examples or previous code, a list of the Bluetooth devices that have been discovered. So some of this will be overlap from previous versions. What we've done is we've made a couple changes and added new functionality. So the onCreate for this activity, we initialize the list of devices to an empty list. We start and bind the services. So we create an intent, which is then supply the service as a class as an input. We then bind the service. We then bind the service with the appropriate intent and service connection, which we'll talk about in a second. We're going to register, as usual, we're going to register the broadcast receivers that we use to pass information back and forth between the service and the main activity. And then now we get to the permissions checking, which we've talked about this several times, how to make sure that not only do we have access to the Bluetooth radio, but the user has already supplied us permission in order to access the course location, which is part of the Bluetooth process. Okay, so then we essentially start the discovery process, which takes us down to the broadcast receiver here and adds a device every time to our list of devices, every time a device is discovered. We give that a certain amount of time, wait time, in order to process. And after that time is over, our discovery process times out. We cancel the discovery process, and we use our find target device method in order to find the one that we're looking for. So this method, essentially what it does is it searches through all the elements in mlist devices, looking for the one with the appropriate name prefix, and we've talked about that before and how that works. Once we've found the appropriate target device, if a valid connection exists, then what we will do is access the service and call the read all characteristics method, passing the desired device to the service, and that leads us to the other part of the code, which is the service itself. So hopefully those two descriptions together give you a good idea of how the main activity works with the service in order to access the Bluetooth information. Okay, next topic that we want to discuss is the auto start service. We've talked about how we want to build something that starts up every time the phone boots and performs a process, which in this case is taking data from the Bluetooth radio and saving it to DynamoDB. And it's really important that this operate in the background because we don't want to be taking up the user's attention every time this update is performed. So there's two potential solutions here. Approach number one is to start application X after the Android OS boot. For this approach, the application or the service is automatically started after Android OS is booted. However, this application will run on a standard system along with any other applications that the user desires. Approach 2 is to replace the default Android home application. Now, this is not the one that we are going to use. This approach makes sense if the device is being used for a single application, such as a cash register. Instead of starting the application X after boot, the application will be initialized upon the system startup and run alone, so you won't see the rest of the OS. We are going to be interested in approach number 1. So the methodology for the auto start activity, which we will also use for the auto start service. When an Android system boots, it sends out a boot complete event known as android.intent.action.bootcompleted. Applications can listen and capture this event to take specific actions, such as automatically generating an activity or service. And below, we're going to talk about how. So we need to begin by starting a new application from scratch. We will add the following permission to the Android manifest.xml file, and that is receive boot complete. We want to give our app permission to receive that broadcast. Now, quickly, we're going to talk about intent and intent filter along with their meanings. We've talked about this before, but there's a good reason to review it here. An intent is a messaging object, again, we use to request an action from another app or component. There are 3 fundamental use cases. The one that we have, or many of you have probably used it for the most, is starting an app or starting a new activity. We can also start a service. This is one that we've talked about before, and this merely requires us to replace within the intent the activity with a service definition. We can also use the intent to deliver a broadcast, and so the broadcast is based on an intent, and then the intent can have other values embedded within it, which we call extras. The primary pieces of information within an intent are the action and then the data. Here, the action that we are talking about is receive boot completed. Now, there are also some important, scratch out those question marks. However, there are also some important secondary attributes such as category, which provides additional information about the action to execute. An intent filter may be defined for each activity reference within an application's manifest file. The filter defines the type of intents that an activity may accept based on 3 elements: the action, the data, and the category. More times than not, we are defining our filter based on the type of action that it is allowed to receive. Next, we are going to add an activity, any generic name, test 001 is fine, to our project. This activity will provide the basis for the project. And then we'll move on to using a service. So once the activity is added to the project, a quick rebuild within Android Studio should add the activity to the manifest within the application node, and then we will add to that 2 intent filters. Action main. As stated above, Android intent action main, or simply action main, is a primary attribute of an intent dictating that the intent will be supplied to the main entry point of the application. This intent filter highlights our activity as a potential entry point for the application, one that does not expect to receive any data. And what this means is we are allowing our activity to accept intents with this action and serve as an entry point to the application. The second is category launcher. As stated above, android.intent.category.launcher, or simply category launcher, is a second attribute of an intent that should appear in the launcher as a top-level application. And so you can see here are the intent filters we added to our application node. Next, we create a simple broadcast receiver class within our application. The code is shown here. It simply starts the activity upon being received. It will act almost like a relay, taking the boot completed action and funneling to our activity. And so you can see here what we have is a broadcast receiver that we will set the filter to boot completed. That will lead us up here into the broadcast receiver, and it will start the appropriate activity that we are looking to call. Now, currently, the Google Play Store requires that all applications be built for SDK 28 or higher. So what do we do if you're trying to build the app for a lower version, SDK 24? The only reason why I bring this up is because the phone I was using was older and would not upgrade to the newest version of Android OS. And I wanted to see if I could still make it work. Now, obviously, one solution is to just go out and buy a new reasonably priced Android phone that runs the newest OS. And there's plenty of options out there that you can find. But again, I wanted to see if it would run on my older version. So what do you do if you're trying to test an app on SDK 24, something lower than 28? Simple. Do not change the target or compile versions of the SDK. You change the min SDK version, and then that should make the app at least testable. Now, this is not the perfect solution because there will be aspects of the app, specifically certain commands or parts of different APIs that will be restricted to certain SDK versions. And so you may need to build multiple versions of a method and specify which SDK it's for. Perhaps the easier solution is to just go out and buy the new phone. But I was able to get by this project using a Motorola Moto 3. I don't know exactly what year it's from, but it doesn't have any more Android OS updates available to it. So when we run this code, we see that the activity automatically starts up after boot and displays the message as expected. So we can take a quick look here at the code. If it will load. All right, so quickly, we've already talked about the broadcast receiver that we used, which simply receives the boot completed message and starts our desired activity. I also included here the Android manifest XML file. You can see that with the it registers the receiver as well as gives the appropriate permissions to the application. And so this actually, yes, that's it. That's all there is to look at. Okay, so now we have completed an auto start application. Let's move on to an auto start service. This is done by creating the appropriate service. In our case, we will simply display the phrase hello world. So this is the service that we are defining right here. And we will update the Android manifest.xml file to include the service. We will then update the receiver to call the service as opposed to the activity. So that is going to change the code right here. Instead of calling test 001 class, it will call our server, our service. And so you can see it makes sense to discuss an auto start application before an auto start service because they are implemented in very similar ways. You can see here we updated our Android manifest.xml file as well as our broadcast receiver to now start a service as opposed to an activity. Now, a big part of this project is going to be saving data to DynamoDB. And so I figured one really good auto start service, one way to test this would be to have something that automatically uploads something to the cloud. Now, note this is not the full project because it is not interacting with the Bluetooth radio yet. So this is, let's say, maybe 45% of the project. that we are looking to complete here. So our next goal is to create an auto start service that simply saves a timestamp to a table every time the phone is booted. And here, for those of you that are not familiar with DynamoDB, are some of the steps in creating a new table. You obviously need to define a partition key or a hash key. And we are going to access our table based on our Amazon resource number. And hopefully I have blocked out all the appropriate information throughout this document. Now, I do spend a little bit of time here talking about Amazon Web Services. I've tried to make this tutorial something that is not too long, but is also not so short, skipping over important parts of the project that one would have to know. So we'll spend a second talking about Amazon Web Services and how to set up this service or prepare Amazon Web Services to participate in this service. Now, once we've created our table, the next thing we must do is create an Amazon Web Services Cognito identity pool. This identity pool is a store of user identity specific to our account. Every pool has a configurable IAM role or multiple roles that will allow us to specify which services our application can access and how. Read versus write, and there's all different versions of that. Typically, a developer will use one identity pool per application. So, user pools are for authentication or identity verification purposes. Within a user pool, our app users can sign in and through a third-party identity provider. Identity pools are for authorization and access control. We can use identity pools to create unique identities for users and give them access to other AWS services. We need an identity pool here because we are authorizing our users to access DynamoDB or a specific table. For this test, we will create an identity pool named this right here, which allows unauthenticated identities to access the services we designate. And so you can see here, if we go into Amazon Web Services Cognito, we manage identity pools, create a new pool. We create roles for both the unauthenticated and the authenticated users. And once we've now created the pool, we need to create the policies. So to give our identity pool and its associated rules the access it needs, we must define an appropriate policy for IAM. We begin with a very simple policy, one that gives our identity pool unrestricted access to all tables stored within DynamoDB under our username. And so this is the most basic policy that we could define. You can use their visual editor, which is helps you to create a policy, but really for very simple policies, it's almost just as easy to go in and write it as a JavaScript object. Pretty simple here. You set the effect, which allows users to perform certain actions. We put a star, so that means all actions. And then for certain resources, but the star again, meaning all the resources that are associated with our username. We give this policy a name, and we review its functionality. So we can see it gives users full access to all of our DynamoDB tables. When we created our identity pool in Cognito, we also created two roles for authenticated and unauthenticated users, which were up here. If we attach our new policy to these pools, these roles, then we will give all members of our identity pool the necessary access to DynamoDB. And so here you can see the process, we access our appropriate role. We then go to attach policies and we choose the policy that we created. Next, we give our application access to Amazon Web Services through the Cognito credentials, which may be accessed from the user console as shown below here. And so the SDK, Amazon Web Services SDK for Android, API for Android, will then utilize this Cognito caching credentials provider in order to provide the application appropriate access. Okay, to access DynamoDB from Android Studio, the IDE must be properly configured. There are 3 different steps. We need to add the appropriate dependencies to the build Gradle, right? The access to the Android SDK DDB mapper and DDB, that stands for DynamoDB. Give the app internet access permission using the Android manifest file. That's important. And then copy and paste the Cognito credentials provider into the app. Now, before we can access DynamoDB, we need to define a mapper class object in Android Studio that manages the interface between AWS and our application. Documentation for this mapper class is available online, and we will define a relatively simple implementation which neglects many capabilities such as batch, read, and write. Our class has the following components. So first, you need a DynamoDB table annotation, which defines the target table's name. So this must be done within the mapper itself. The attributes, which define the attributes for an individual table entry. The most important attribute is the primary partition key, which is composed of the hash key and the optional range key. Our hash key is a string referred to as timestamp. Now, we need to use Java Bean-based mapping with appropriately named get and set methods. A Java Bean is a plain old Java object that is serializable, has no argument constructor, and allows access to properties using getter, setter methods that follow a simple naming convention. In our case, if we use get timestamp to access the timestamp, then the corresponding setter must be named set timestamp. Get timestamp and set timestamp. Our second attribute is a message and therefore has the corresponding methods of get, message, and set message. So let's take a look quickly if it will let me at the mapper. Okay, so this is the mapper class. Like I said, we need to define the table name, which is shown up top, public class element mapper test 004. We have our class variables. There are 2, the string mHashkey and the string message. We have our constructors. There are 2. Java Bean requires a no argument constructor. We can also include an argumented or a constructor to which arguments may be passed. Then we have our Java Bean based mapping. We define our getter methods. There are 2, get timestamp and get message. Get timestamp has the appropriate at DynamoDB hash key annotation. The attribute name is timestamp. And then we define our setter method. So for this very simple structure, this very simple entry to one of the DynamoDB tables, there is not much that needs to be supplied. Okay, next we shift our focus back to the primary activity, and let's add a test item to the table using the online console. So I did this using the AWS online console, and this will give us a way to verify table access. So we then use code to create a DynamoDB client and perform several read-write operations drawing from the structure defined within our mapper class, as we showed a second ago.
Okay, so we've talked about DynamoDB, we've talked about Amazon Web Services, And it says here we didn't finish the last example. I actually didn't talk about the last example. We're going to move on to the next one. And our goals, the reason why we didn't is because our goal is to create an auto start service, not an activity that reads all characteristic values from Bluetooth, from the Bluetooth device and automatically uploads them to DynamoDB. So we're going to take a look at what we've learned before and then parse through it. Now, this is getting very close to the code that we talked about in the beginning. And so I'm slowly going to drop off here. This is toward the end of the video, because I don't want to reiterate a lot of what has already been said before. So there is some frustration working with auto start services because they don't always seem to work, even when properly implemented. They don't seem to work on the first reboot after application install. They seem to work more reliably on the second plus reboots. Second, they work better when not connected to a PC in debugging mode, especially when showing the log screen. It seems to slow down the mobile device. Third, associating the service with an activity, which I thought initially helped, didn't really necessarily seem to help. So really basic, we create a new project, we define a basic auto start service, which extends class service. This is what's going to boot up. Again, very much repetitive of what we learned previously. When the mobile device boots, it sends out a broadcast with the action intent boot completed. If we create an appropriate broadcast receiver, and register it with the proper intent filter within our Android manifest.xml, the code contained within the broadcast receiver will be executed upon boot. We must perform 3 tasks here. We define the broadcast receiver, we give the application permission to receive boot complete, and we register the broadcast receiver such that it automatically just starts our desired service. And so you can see here, right, this is the broadcast receiver that receives our boot completed message, and it just goes ahead and starts our service. Defining the service, again, I don't really think there's that much that we can put in here or say that hasn't already been said. This is the very beginning of our service. Obviously in here is where we have all the different aspects of the code that were shown at the beginning of this video. We need to define a launcher activity, because the launcher activity it must be run the first time, and it's that which allows the user to give us proper permissions. And you can see everything ran properly. We add our Bluetooth functionality, which is shown here. Again, some repetition. We permission for internet access, Bluetooth admin, access course location, and the receive boot complete. And so what we do here is we start bringing code from some of our previous projects and moving them into this. Now, again, I'm not going to go through a lot of this code. It's very repetitive. You can see here we're checking for permission. We request permission if we don't have it. And if we do have permission, then we essentially start our service, which would normally be started after boot. So this is the main activity that starts everything. We added DynamoDB functionality. We talked about that, creating a new DynamoDB table, getting our identity pool incognito. We talked about this at length. This is an example of how you can create the policy in using the AWS online user console. We get our Amazon resource number. We attach the policies to the roles in IAM. We acquire our Cognito credentials. We add the appropriate dependencies and permissions. There were more permissions in this, as you remember, but we can't forget to add these dependencies here, which allow, will essentially give the application or the service the necessary libraries required to connect to our DynamoDB table. And this is pretty much the end of the road, because this example is the one that we started off with. The auto start service that saves Bluetooth values to DynamoDB. And the one reason why I cut the last example short and sort of made a different version of it, again, which we presented at the beginning, there were several problems. There was a lack of synchronization. Our code had both the BLE and Android device running on infinite loops, reading the Bluetooth value. This was fine for initial tests where some of the communication was the objective. Some sort of communication was the objective. However, as we move towards the final version, we need to include some sort of synchronization, handshaking, where hardware controls the flow of information in a more organized way. And that's where we implemented what we've talked about before, this structure for the Bluetooth values, where essentially a service that I define is broken up into several characteristics. We have the name, we have the value. So this is the important part we're trying to extract. We have the random ID, which again came into play when we're trying to determine whether we're getting repeat values over and over again, which shouldn't happen if we are setting our status correctly. If we are setting our status to true, after we read it, that should shut off the advertising. But just in case, we assign this random ID, so it's a number between 1 and 1,000. So if we happen to get 531 two times, we know that the chances of it generating the same random number are low, and so we can ignore that reading. And so that takes us back to the very beginning of this video. I tried my best to address the parts of this document that were most important to understanding the beginning. This is obviously not a full course on building Bluetooth and DynamoDB related or adjacent Android services. However, for me, I focused on the questions that were most difficult for me to answer. And most of that could be broken up into a couple different categories. The things that I found most difficult to tackle. Number one was the general structure of the app or of the service, and I talked about that in the beginning. The use of listeners and broadcasters and different functions that are able together to cycle through all of the elements of a Bluetooth Gatt, access all the services, access all the characteristics, and then determine when that's done and save it to DynamoDB. There's also the other preliminary part of that structure where the adapter tries to discover new devices, builds a list of devices, and then finds the target element. Number two was definitely the permission checking. That didn't take a lot of time, but it was a little bit of a roadblock. I was not assuming that we were going to have to jump through that many hoops in order to get access to the Bluetooth radio. I'm not exactly sure how the Bluetooth radio allows you to access location information, but I guess there's some way to do that. Number three is just the use of the Bluetooth API. I was very familiar with the DynamoDB and pretty much all of the AWS APIs. The Bluetooth API threw me for a little bit of a loop, especially how they had it structured with the Gatt callback function and everything having to be sort of routed through that after you call the connect Gatt method. But after I understood how things worked, right, you call the read method, and then that leads you to on characteristic read, and then you can do whatever you want from there. And again, if you write something, it leads you to on characteristic write. So once you understood that, and I think I did a pretty good job of explaining that in the beginning, you get a sense for how the flow works. But the commands were not so inherently obvious how to use in the beginning. One thing especially that threw me for a loop was the separate read characteristic and then get characteristic methods. Right, reading brings it in from the Bluetooth radio, whereas get characteristics spits it out to Android where you can actually view it. And then I think lastly, there's just so many different timing issues. The not allowing the Android device to keep searching forever, how to minimize the energy that would be lost from constantly advertising. And then five, I mean, I just talked about it above, but this way of organizing the data, the Bluetooth data, this really helped because, and you don't necessarily have to do it the way that I did it, but I recommend you do something because just passing a whole bunch of Bluetooth values that are merely identified by their characteristic ID, without any sort of higher level structure, it was problematic, and it was hard to keep track of values. So I definitely recommend that you build services that collect a group of characteristic values that all describe or are associated with one another. And I would suggest you build different services for different values. So let's say you're trying to collect temperature and let's say other readings from sensors. I think it makes more sense to structure them as different services, each with characteristics that follow some sort of structure. So you can get an idea of what's going on. You can tell what the status of a read is. This random int helped in certain cases. And then, trying to put the name of the characteristic in there also helped. This was difficult because you are limited by the length of the data that you can pass. So you're not going to be able to pass a really long name. But you can perhaps pass something that at least is the first couple letters, and that way when you're running your code, you can always check that characteristic and say, okay, I'm on the right track. I actually just passed the names in sort of a roundabout way where I passed them as doubles or integers and then decoded them into bytes and then used ASCII in order to get the name, because that was a little bit more, that gave me a little bit more room or ability to transmit a longer name. There is no string characteristic, so that is a little bit unfortunate. So that's the end. Thank you all for checking this out. If you want to see some other stuff, I recommend you check out. That's two E's. Check out my website, which is here. And there's tons of other cool stuff in here. Advanced tutorials section, you can see there's stuff that I have not done videos on. You can click on hardware, let's say Eagle, PCB design and fabrication, software. There's more basic stuff on Android Studio and simple storage service, using JavaScript and working with the Google Nest thermostat, the Twitter API and RESTful architectures. That was right. The RESTful architecture is what they use to communicate with Twitter. So there's tons of good stuff on there that you can check out. This video is on my YouTube channel, which you'll see right now has a bunch of stuff related to courses that I'm teaching, electronics and circuits. But now I'm trying to add newer videos that are interesting to a wider audience, and actually a little bit more interesting to me, because this is the type of stuff that I am working on right now.